We'll start off by talking about how to enable or disable advanced virtual machine settings. Now, this isn't something that you'll be doing every day as a vSphere administrator, but it's also important to know where and how to find the advanced virtual machine settings. Here in the vSphere client, if we select one of these virtual machines, it really doesn't matter which one, and then click on the settings icon, we'll go into edit the settings, and then we've spent a lot of time here working with virtual hardware. But if we go into the VM options, there's actually a lot in here. All of these are collapsed by default, but if you expand out each one of these different sections, there's actually a lot of information in each. Now, when it comes to advanced virtual machine settings, if you go on down to advanced here, that is a section inside VM options, and then take a look at what we have in advanced virtual machine settings. The first one is disable acceleration, and this would only be used in specific use cases where you have an application inside that appears to stop responding. This could be used to troubleshoot that application. And then you have logging, which is enabled by default. There is a virtual machine log file, and we'll talk about that here in just a moment because it can be very helpful when it comes to troubleshooting problems with a virtual machine. You can see here inside debugging and statistics, the default is to run normally, but you also have options to record debugging information and record statistics if you need more details from your logging and debugging data. You can also choose to move the location of the virtual machine swap file from the default. The default is to store the virtual machine swap file. And again, we'll talk more about specific virtual machine files in an upcoming lesson. The default is to store the virtual machine swap file with the host or cluster that contains the virtual machine. And we'll talk more in an upcoming lesson about specific virtual machine files like the virtual machine swap. But if we wanted to, we could choose to store the swap file in the same directory as the virtual machine, or even to store the virtual machine swap file in a specific data store that would be just used for swap files. However, keep in mind that that could cause the virtual machine to not be able to be vMotioned or cause performance problems for the virtual machine. We'll leave the default here as we do with really all of these advanced virtual machine settings. Like I said, these aren't things that you want to go in and change without a good reason and without full understanding. Next up here underneath configuration parameters, if you click edit configuration, this is typically what we're talking about when we refer to advanced virtual machine configuration parameters. This is a very long list of configuration parameters, again, that you don't want to change unless you have a specific use case. And when we go in and look at the virtual machine configuration file, you'll see many of these in that file. But if you did need to change a virtual machine configuration file, this is where you would go in and do it. However, you might notice here that none of these seem to be able to be edited. In order to edit the virtual machine configuration files, we're going to have to cancel out of here, and then we'll shut down the guest operating system. And once the virtual machine is powered off, we'll go back in to edit the settings, into VM options, down to advanced, and then into edit configuration. And now you can see this is where you can go in and change these values just like this. You can also go in and add new configuration parameters. I'm just making this up as an example. This is obviously not a real configuration parameter, but you can see this is a key value store where you have a name or a key, and then you have a value for that key. And again, you'll see these in the VMX configuration file when we go and look at that file in an upcoming lesson in this module. So that's how you change virtual machine configuration files. There is one last setting here underneath advanced, and that is latency sensitivity. There may be cases where you have applications that are highly latency sensitive, and I'm talking about specialized applications like voice over IP or high frequency trading applications. where you might want to enable this latency sensitivity setting. So that's what you need to know about advanced virtual machine configuration options here inside the virtual machine settings. A virtual machine is a software construct of a physical hardware computer. So, what that means is if you think about a physical computer, that computer is going to have CPU, memory, networking, storage, BIOS configuration, swap files, also known as memory paging, and a whole long list of other configurations. Well, with VMware vSphere, all of those things are represented in software, which really means they're represented in files or in data. Here in the VMware 7 documentation over at vmware.com, if you look at this page that covers specific virtual machine files, you can scroll down. And instead of me trying to put this on a slide, I just thought it would be better to show you the official VMware documentation because there is a long list of files that make up a virtual machine. Starting with the VMX file, which is also known as the virtual machine configuration file, and we'll be opening up one of those and exploring it more in the next lesson. And then there's also the VMXF file, which is the additional virtual machine configuration file used in some cases. Then you have what's much more common, and that is the virtual machine disk file, also known as the VMDK. However, the VMDK really just points to the virtual machine disk characteristics, and the -flat VMDK file is the real virtual machine data disk. Then you have the NVRAM file, which is the actual virtual machine BIOS or EFI configuration. That represents the BIOS of the physical computer. Next up is the VMSD file, which is the virtual machine snapshot file. And then the VMSN file, which is the actual virtual machine snapshot data. And then we have the VSWP file, the virtual machine swap file. This is the memory paging file. Just like in Windows, where you have a swap file, every virtual machine also has a swap file in case the virtual machine's memory is overutilized. Then there's the VMSS file, which is the virtual machine suspend file. If you choose to suspend a virtual machine, the state and memory of that VM will be written to the virtual machine suspend file. Then there's the VMware log file. This is the current virtual machine logging data, and we'll look at that here in just a moment. And then older virtual machine log files have a dash with an incrementing number, followed by the .log file extension. If we go to a specific virtual machine and we look at the settings for that VM and go into the virtual machine options and then general options, it's here that you'll find the location of the virtual machine configuration file. That's the VMX file. That's the configuration file for the entire virtual machine. And then there's the working location, basically the home directory, if you will, for the virtual machine. So to see these files on disk, in the case of this virtual machine, we'll go to the vSAN data store. Here into the storage inventory, I'll go into vSAN and then into the Files tab. And here you can see there's a folder for each one of the virtual machines. In our case, we were looking at WebWin2, I believe it was. Is that correct? Yes, WebWin2. So if we click on WebWin2, this is the virtual machine home directory. And we can expand this out a little bit so that you can see this in greater detail. And let's try to just go down the list and look at each one of these. So we have the VMware-1 log files. Then there's -2, -3. These are the older archived log data for the virtual machine. And then there's the VMware.log. This is the current log file for this virtual machine. In fact, if we download this file, you can see this is all the logging data for the virtual machine. So when this virtual machine is powered on, when anything happens with this virtual machine, when it's reconfigured, when there's an error, all of it goes into this virtual machine log file. So if you're having trouble with a virtual machine, things aren't working as expected, this is likely where you want to go look. And of course, in our vSphere 7 troubleshooting course, we'll be exploring these types of log files in much greater detail. And then there's the .hlog file. In fact, if we go back to the virtual machine configuration file documentation, it does mention here that there is a .hlog file that can be used by vCenter to keep track of virtual machine files that must be removed after a certain operation completes. Going back to the virtual machine file list, here's the .nvram file. This is the non-volatile memory, also known as the BIOS. If you recall, virtual machine BIOS or EFI configuration file is the .nvram file. And then we have the VMDK, which is the virtual machine disk file. And you can tell that obviously by the size of this. This is roughly 25 gigabytes. So obviously that is the virtual machine disk. That is where the virtual machine is storing all of its data. Then we have the VMSD file. If you recall, VMSD is the virtual machine snapshot file. Now, this virtual machine does not have any snapshots taken of it, but if you had taken virtual machine snapshots, you can see the size of this file would not be 0 kilobytes. It would be much larger. And those virtual machine snapshot files can grow and grow and grow over time and actually consume a lot of disk space. So that's something to keep an eye out for. And then we have the actual VMX file. This is the virtual machine configuration file. This is really what represents the configuration for the entire virtual machine. In fact, if you had a virtual machine on disk represented by a bunch of files, you would use this VMX configuration file to actually register the virtual machine as part of a vSphere infrastructure. Next, we have the VMXF file. This is the VMX configuration file, but it has some extra information in it. And then finally, we have a second virtual machine disk file on this virtual machine that we created. So this virtual machine actually has two different virtual disks on it. So it has two different VMDK files. If we go back to the virtual machine and then we look at its configuration, you can see it has hard disk 1, and there's the actual path to the VMDK. And then there's hard disk 2. And then it has its own unique path to its own unique VMDK, which ends in _1.vmdk. And that's exactly what we're looking at over here. When we look at the files for this virtual machine, you can see VMDK1 here and VMDK2, although it ends in _1. So I know that can be a little bit confusing, but I should say the first virtual machine disk is up here. It's 25 gigabytes. The second virtual machine disk is down here, and it's 2 gigabytes. Now, typically you don't want to modify or change these files in any way on disk. I will show you in the next lesson the VMX configuration file, how to look at it, and it is possible to deregister a virtual machine, make changes to that file, and then re-register a virtual machine. However, I would only do that in rare instances for very specific use cases. Typically, all the configurations you want to do, you're going to do using the vSphere client by editing the settings of the virtual machine. That's the safe way. That's the best practice. Don't be editing any virtual machine configuration files on disk. As we talked about, the VMX file is the primary virtual machine configuration file. This is what you would use to register a virtual machine that was on disk. And should you need to do so, modify the virtual machine configuration manually. If we look at the virtual machine that we've been working with and go into its virtual machine home directory, it's here that you'll find the VMX configuration file, webwin2.vmx. And you can see that vCenter just calls this file the virtual machine. It references the entire virtual machine by that file. So if we download the VMX configuration file and go ahead and save it, and if we look at the file that we downloaded, I'll just right click it, and let's say we want to open it up with the text editor. Let me go ahead and make this text a little bit larger, a little bit more readable. And you may recognize many of these key and values when we looked at the advanced virtual machine settings. But this is the VMX configuration file. This represents the entire virtual machine configuration. Let's just go down the list here and I'll highlight some of the values that resonate with me. The first one being that this is virtual machine hardware version 17. We talked about the different types of virtual machine hardware, the different versions, with version 17 being the latest and greatest as of the release of vSphere 7. You can see that this virtual machine does not have a virtual floppy. It has 4 virtual CPUs or 4 vCPUs, and it has 4 gigabytes of memory. That's the mem size. 4096 represents 4096 megabytes or 4 gigabytes. It's using the EFI firmware for its BIOS. It does have a SCSI controller. That's true. It also has an NVMe disk controller. You can see here we have a SATA virtual CD DVD drive. And if we scroll on down, here's the name of our first virtual machine disk file, webwin2.vmdk. Moving on down, this virtual machine does have a virtual network interface card. That's Ethernet 0, and it's an E1000E. That is a type of virtual network interface. It's connected to the VM network. That's the virtual network it's connected to. And you can see it's automatically generated Ethernet MAC address. The name of this virtual machine is webwin2. Now, you might think that that would be at the very top, but I can tell you that these VMX configuration files don't really have things organized very well. I'm sorry to say. The settings are a little bit kind of jumbled up in here and in no particular order. So that is the name of the virtual machine, webwin2. Its guest operating system is Windows 2019 Server, 64-bit. And if we scroll on down, you can see here the name of the NVRAM configuration file. We looked at that in the virtual machine's home directory. I'm not going to go into every one of these settings. We have 2 cores per socket configured. We saw earlier up here that we had, where was it? 4 vCPUs. But if we scroll on down, we have 2 cores per socket. And we'll be talking about cores versus sockets in an upcoming lesson, so keep that in mind. Moving on down, there's a lot more detail in here that we're not going to go into. But one of the settings that does catch my eye is the name of our second virtual hard disk that we added right here, webwin2_1.vmdk. That's the second virtual machine disk file that you saw in the virtual machine home directory. And notice how it's a SCSI disk type, whereas the other virtual machine hard disk was an NVMe disk type. Now, if I did want to change a setting in here, for example, the virtual machine name or the number of CPUs or the amount of memory, I could deregister this virtual machine from vSphere. I could make that change on this VMX configuration file. I could re-upload it back to the virtual machine home directory and then re-register the virtual machine with vSphere, and then that change would be made. However, like I said, it's much easier to just simply go to the virtual machine here in the vSphere client and edit the settings yourself. So that's what you need to know about the VMX configuration file, the virtual machine configuration file in vSphere. It's the most important of all the files in a virtual machine's home directory. Most every virtual machine in your vSphere inventory is going to have more than one virtual CPU. But there's also this concept of cores. Let's talk about the difference between CPUs, cores, sockets. All these things can get quite confusing. Here's what you need to know. First off, you have the traditional CPU. When we think of CPU, we think of the big Intel or AMD CPU that we plug into the motherboard of a computer. And with virtualization, honestly, it's no different. The physical hosts, they still have CPUs, and those CPUs plug into CPU sockets. And while traditionally each CPU only had a single core, today CPUs can have multiple cores. In fact, they typically do. And you can think of a core just like a miniature CPU inside each CPU socket. For example, let's say that this is a physical CPU. Inside that physical CPU that we're going to insert in the physical server, That CPU will have one, maybe two, maybe three, maybe four, sometimes 8 or 16 CPU cores all inside this physical CPU. And honestly, your virtual machines are going to work no differently. Every virtual machine can have one or multiple CPUs, and then those CPUs can have one or multiple cores inside. Here in the vSphere client, if we look at this virtual machine, you can see the virtual machine hardware says it has 4 CPUs. If we go in and edit the virtual machine settings and expand out the number of CPUs, notice here that it has 2 cores per socket and 2 sockets for a total of 4 CPUs. And in fact, if we go into the virtual machine itself, into the operating system, and then into view the processor settings, you can see it says we have just 2 processors. However, if we go into system information, notice it says that we have, yes, 2 processors here, but each processor has 2 cores. So we have a total of 4 cores spread across our 2 different processors, or our 2 different CPUs. Now, if we wanted to shut down our operating system, we could go in and edit the settings and change the number of CPUs. For example, we could say we wanted just 1 core per socket and still have 4 CPUs for a total of 4 sockets. So if we went back inside the guest operating system and looked at the system information, you would see that we have 4 Intel CPUs, but each having its own core. So just 4 cores spread across 4 CPUs. On the other hand, you could change this and you could say you want 12 CPUs and you want 12 cores per socket. Let's find out what would happen then. If we say OK, we reconfigure the virtual machine, we'll power it on. And of course, it's important to point out that your guest operating system has to support the number of CPUs. Just because you configure a lot of CPUs and a lot of memory doesn't mean your guest operating system is always going to support that. If we go back into this guest OS and we look at our CPU information, Windows says we just have 1 CPU. However, if we go into our system information, here you can see we just have 1 CPU, but notice how we have 12 cores in that CPU. If we go back to our system settings, you can see we just have 1 socket configured, but 12 cores per socket. I hope this is starting to make a little bit more sense. If we shut down the guest operating system one more time, let's go back in and configure our CPUs and our CPU cores. And if we go back in and edit the settings, we could change this back to, for example, 4, but we could configure 4 cores per socket. Something else you should be aware of here is the ability to enable CPU hot add. That means that without having to reboot the guest operating system, I can add more CPUs to a virtual machine. Now, your virtual machine guest operating system has to support this as well, but it must be first enabled in the virtual hardware when you go into virtual machine settings. Besides understanding the difference between CPU cores and sockets, it's also important to keep in mind the limitations around multi-core vCPU configurations. Specifically, you can have up to a maximum of 128 virtual CPUs assigned to a virtual machine, but that number is going to be less depending on the number of logical CPUs on the host server, as well as the type of guest operating system installed in the virtual machine. Also, not every guest operating system is going to support what VMware calls virtual SMP, or virtual symmetrical multiprocessing. I hope you enjoyed this lesson on configuring virtual machines for multi-core vCPUs. We'll talk more about this in our vSphere Performance course. There are scenarios where your applications running inside a virtual machine might need access to a specific USB device, such as a USB licensing or a security dongle. Now, traditionally with virtual machines, this is kind of hard to do, and it's especially true with virtual machines moving dynamically from one host to another host. However, for the most part, VMware has come up with a solution to all of these problems by providing what they call USB pass through and then a USB arbitrator. You can think of USB arbitrators essentially as a piece of software that allows multiple virtual machines to connect to a USB hardware device, even as those virtual machines move around. Now, there is a limitation with the number of USB controllers being 15 as the maximum number of USB controllers that can connect to a USB arbitrator in vSphere. Here in the vSphere client, let's say that I wanted to connect a USB dongle or USB device that's on a physical ESXi host to this virtual machine. To make that possible, we go into the settings for the virtual machine, and then what I need to do here is to add a new USB device. And then what you need to do is to add a new device. However, first, you want to make sure that you have a USB controller. In this case, a USB controller is created by default with this virtual machine type and this virtual machine hardware version. From here, I can click to add a new device. And what you want to add is a new host USB device. I'll select new host USB device. And then you can see right here, it immediately recognized we do have a USB device on the host that this virtual machine is connected to. It gives us the name of that USB device. And if we had more than one USB device on the host, we would of course have a drop down here where we could select the USB device that we wanted to connect to this virtual machine. It tells us that the connection to this USB device is available on the host. And if we click OK, this USB device would be connected to the virtual machine. But first, I want to point out that you have the option here to support vMotion while this device is connected. So that means as this virtual machine moves from host to host, even though the USB device stays on the original host that the virtual machine was running on, the virtual machine and its applications still have access to the USB device that you configured. Keep in mind that if distributed power management is enabled on the cluster where this virtual machine is running, you would want to disable DPM or use some affinity rules to keep the virtual machine from migrating from one host to another host and then being shut off automatically with distributed power management. Also keep in mind that if the virtual machine powers off and then back on, the host USB device might not be connected to the virtual machine anymore. So that's another reason to keep the virtual machine powered on, and also ideally keep it on the host with the physical USB device if possible. However, like we said, vMotion is supported with vSphere thanks to VMware's USB arbitrator. There are many use cases where you need virtual GPUs or vGPUs accessible for specific applications inside a virtual machine. Maybe you have a graphic designer who's running a virtual desktop. Hey, maybe you even want to do some Bitcoin mining. This is possible with a vGPU added to a virtual machine. Here in the vSphere web client, let's go to a virtual machine that's already powered off. Go in to edit the settings for this VM, and then take a look at the video card. If we look at the video card, you can see you can auto detect. In our case, we have custom settings. You can specify the number of displays. Yes, you can have up to 10. You can specify the size of the video memory. The default is 4 megabytes. You can enable 3D support and configure the size of the 3D memory as well. You can also configure where you want the 3D rendering to happen, either in hardware or software, but there's no mention here of vGPUs. So how do you get a vGPU in a virtual machine? Well, you should know that GPUs have to be physically inserted into your ESXi host. And to share those GPUs, it's recommended to use something called NVIDIA vGPUs. If we open a new tab, let's search for NVIDIA vGPU on vSphere. And of course, you can find more information at nvidia.com. This is a solution that you're going to install not only with physical GPUs into the host, but also with a VIB, which is a software driver, onto each of your ESXi hosts. And then once NVIDIA vGPU is available on the host, you can go back into the ESXi host configuration. And here underneath hardware, you'll find a new section for graphics. And it's there that you can select either a shared virtual graphic or what they call a shared direct, which is a vendor shared pass-through graphics option. Once you have the GPU installed as well as the associated software, you'll be able to go into your virtual machines and then add a new PCI device. And as you can see here, NVIDIA Grid vGPU is the default option. That is selected NVIDIA Grid GPU, but we don't yet have any sort of profile because we really don't have NVIDIA Grid vGPU installed at this point. Something else to note is not only do you need the physical GPU as well as the VIB installed on your ESXi host, but each guest operating system will also need a GPU graphics driver. So that's what you need to know about using vGPUs with VMware vSphere. And with that, let's wrap up this module.